Okay, we're starting Chapter 5 on decimals. First is Section 5.1, Introduction to Decimals. So when we're looking at decimals, we're going to use the set of digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And it's going to be kind of like whole numbers. That's how we're going to look at it. And so what we're going to have is it's going to be basically a whole number part and then a decimal part. And so what we have is we have the decimal point, and that's at this point right here. Whoops. And so what we have is from each direction we can go, to the left we're going to go up and to the right we're going to go down. So here we have the 9, which is in the ones position. Then the 8 is in the tens position. The 4 is in the hundreds position. The 3 is in the thousands. The 5 is in the 10,000s, and the 7 is in the 100,000s. So normally if we would have this as a whole number, we'd sometimes put a comma right there. Now if we go to the right, what we're going to do is we're going to go to the tenths, which is going to be the 2, so that's the tenths position. Then next one over, we're going to move by factors of 10, so that's going to be the hundredths position. Then we have the thousandths position. Then we have the 10,000ths position. And finally, we have the 100,000ths position. Okay. And so if we go from one position to the next, going from right to left, we're basically going to be multiplying by 10. So this is ones times 10 is 10, times 10 is the hundreds, times 10 is the thousands, times 10 is the 10,000s, and times 10 is the 100,000s. So that's how we get those. And here we're going to start at the tenths, and we're going to keep dividing by 10, basically, or multiplying by 1/10. So tenths, and then 1/10 times 1/10 is 100th, and then 1,000th, and then a 10,000th, and then a 100,000th. So these we're going by the tenths. All right, so how do you read a decimal? So basically, we're going to pronounce the whole number part to the left of the decimal, as you would say any whole number. Then we'll say and for the decimal. And then we'll state the fractional part to the right of the decimal as you would any whole number, followed by the place value of the rightmost digit. Now note that the and here, where we have this decimal, that's the only time we actually have and in a number is at that decimal point. So you won't have a decimal anywhere in the whole number and anywhere in the part to the right of the decimal either. So what we're going to do is we're going to look at kind of the expanded form. So whole numbers we've seen, we have 23,452. So we expanded it and we said, okay, well, the 2's in a 10,000, so we have 20,000. The 3 is in a thousands place, so that's plus 3,000. The 4 is in the hundreds place, and so that's going to be 400. The 5 is in the tens place, so that's going to be 50. And the 2's in the ones, so that's 2. So we just take and add those together, and that's our expanded form of a whole number. And like I had said, we pronounce this 23,452. Notice no ands. Now for a decimal number, such as this one, what we're going to do is we're going to expand the whole number part and do kind of like we did up here. So we'll have 5 in the hundreds place, so that's 500. 2 in the tens, so that's going to be 20. 1 in the ones, so that's going to be 1. So that's the 521. And then we have our point, so that's going to be the and then we'll have here, that's the tenths, so that's going to be 2 over 10. Then we'll have the 3 is in the hundredths, so that's going to be 3 over 100. The 4 is in the thousandths, so that'd be 4 over 1,000. And 5 is in the 10,000ths, and so that'd be 5 over 10,000. So that's the expanded form. We just add all those together, and that's going to be our expanded form. And then if we have a combined form, basically what we're going to do is we're going to combine the whole number part, and we're going to combine the fraction part, and then we'll have, sometimes we'll have it added together for the combined. A little later we'll have it combined as a mixed fraction, so we'll just put 521, and then we'll drop the plus, and we'll have 2,345 10,000s. Okay, so this is kind of your combined, and again, like I said, once we do the mixed fraction, we'll just drop the plus and we'll put the 521 next to that and have a little space. Now we pronounce this 521 and 2,345 10,000s, okay, because that's in the tens, hundredths, thousandth, 10,000th place. So that's why the 10,000th here, okay. So that's how we would do this one. Now let's look at an example here. So we want to write this in an expanded form. So in expanded form, we would have 46, so that's going to be 4 tens, so that's going to be 40, plus 6 is in a 1, so that's going to be 6, plus, now we have 1 in a 10th position, so that's going to be 1 over 10, plus, now 3 is in the 100th position, so that's 3 over 100, and then plus, now we have 9 in the 1000th position, so that's over 1000. So that's going to be our expanded form. Now what we want to do is we want to do kind of the combined form. So that's going to be 46 plus, now that's going to be 139 over 1000. So that's how we put all that together and we get it. And if we think about it, if we had to get common denominators, we'd have to multiply that one, by 100, that one by 10. And so it'd be 100, 3 tens, and 9 ones. And so that would give us 100, 3 tens, 9 ones, 139, all over our 1000. And we would write this 46 and 139 thousandths. Oops. Okay. And so that's how we would do that one. Okay. And again, if we wanted to have the combined form and we say we wanted a mixed fraction, so the mixed fraction, what we would have is 46 and then just 139 over 1000, and that would be our mixed fraction form. From there, we could get to an improper fraction or do whatever we needed to do with that. But that's how we would write it in expanded form first, then the combined form, then the mixed fraction, and how we would write it out and pronounce it. All right, so converting decimals to fractions. So how are we going to do that? Well, we're going to write the decimal in a combined form first. And basically, we're going to get it all the way. We're going to do combined, and then we'll convert it to the mixed fraction. So we'll get rid of that plus. And then, so that's what this part over here says. We're going to reduce it to a whole number and a single fraction. And then we're going to convert the whole thing to an improper fraction. So that's how we convert the decimal to a fraction, because we're going to go to an improper fraction. And the thing to note is the denominator is going to have the same number of zeros as the number of decimal places. And we can see that with this one, we have 1, 2, 3, better use my pen here, 1, 2, 3 decimal places, and we have 1, 2, 3 zeros, okay? So that's where we're going to get our number of zeros if we ever have questions. And that all comes back to going to, the 3, 1, 2, 3 thousandths. So that's over 1,000, and that's going to be in the 6 there, all right? So that's how we're going to convert decimals to fractions. So what we're going to do is we're going to do a couple. So we're going to convert first to a mixed fraction, and then we're going to convert it to an improper fraction, but we're not going to reduce. So the first two we're not going to reduce. All right, so what we have is we have our first part, so that's going to be our whole number, 625. And now, remember, all we have to do is write this number, 591, over, and then we have 1, 2, 3 spaces, so it's going to be 1 with 1, 2, 3 zeros, 591 thousandths. And so that's going to be our mixed fraction. And an improper fraction, well, we're just going to do like we normally do. We're take this times this plus that. So it's going to be 625,591 all over 1,000. Okay, so that's going to be our mixed fraction. That right here, this is going to be our improper fraction, and that's how we get to it. Same thing we go here. We look and get our whole number first, which is 915. So we write that down for our mixed fraction. And now we have our decimal part, which is 239. And that's over again, 1, 2, 3 zeros. So it's going to be over 1,000. So it's 915 and 239 thousandths. Now, if we want to convert that to our improper fraction, we'll take 1,000 times 915. So it's going to be 915,000 plus that, which is 239, all over our 1,000. So that's our improper fraction, and that's our mixed fraction. Now down here, what we want to do is we want to convert it to a fraction, but then what we want to eventually do is reduce it. So while it's going to be easier to do these if they're like just the decimal part, no whole number, you can do it even for the whole number part as well, but it just makes it a little more difficult. So if we want to do this, down here on the bottom, we'll have 35 over 120. So it's going to be 35 over 100. So that's 35 hundredths, which is what we have here. So now what can we do? Well, 5 can reduce in here. So 5 will go in here 7 times. 5 will go in here 20 times. Well, we can't reduce that anymore, so that just is 7 over 20. Okay, so that's how we've converted first to a fraction. So that was 35 over 100. We reduced it now to 7 over 20. All right, same thing's going to happen over here. 0.98, that's going to give us 98 hundredths, so 98 over 100. Now if we divide by 2 on both of them, for sure that will happen. So if you divide the bottom by 2, that's 50. Divide the top one by 2, that's 49. So now 49 and 50, well, that's as far as we can reduce, so that's going to be 49 fiftieths. Okay? And that's what we have for a reduced fraction there. And again, you can do this with the whole numbers in front of it, but it's a lot easier if we're just doing just the decimal part. So this would be like 35% or 98%, and that's kind of what we're going to eventually use it for, is converting a percentage to a decimal and then a decimal back to a percentage. All right, so rounding decimals. So this is basically going to work exactly the same as rounding whole numbers, except we're going to have a decimal piece there, and we're going to actually get to just drop things at the end. So we're going to still have our rounding digit. So it's a digit we wish to place, which we wish to round to. So, you know, maybe we went around to the 10th or the 100th or the 1000th or whatever position. And then we have the test digit, which is basically the digit to the right of the rounding digit. And so as we did before, if the test digit is greater than or equal to 5, we're going to add 1 to the rounding digit. And then what happens is with the decimals, we just truncate all the digits to the right of the rounding digit. So they just all disappear. So we don't have anything to the right of it. And if the test digit is less than 5, basically we simply truncate all the digits to the right of the rounding digit and we're done. So let's look at this one. So let's say we have 79.369 and we went around that to the 10th. So that's to this position here. So that's going to be our rounding digit. This is our test digit. So is 6 greater than or equal to 5? Yes. So that means we're going to round that up. And so it's going to be 79.4 and we're going to drop everything else after that. And so what we've done now is we've taken 79.369, rounded it to the nearest 10th, and so that's our 10th position, and that's what we have. Now if we want to round the same one to the 100th, so let's say we have 79.369, well the 100th is this position, so we need to have that as the rounding digit. This is our test digit, and so what does that give us? Well, that's going to say that's going to be our number that's greater than or equal to 5. So, you know, we've got that part here fulfilled. So that means we want to round this number up by 1. So 79.37, and then we drop everything else. And that's going to be our number here rounded to the 100th. Okay. And we'll do some more examples of those later in another video. Let's do this one, and we'll do to 3 different places. So first time, we're going to round 71.2427 to the 10th. Well, the 10th is right here, so that's our rounding digit. And our test digit is 4. Well, 4 is not greater than or equal to 5. It's less than. So basically what we do is we drop everything over here, and we've got 71.2 as our rounded answer for the 10th. Now the 100th, 71.2427. Now the 100th is the second position. We're using that as our test digit. 2, again, is not greater than or equal to 5. So that 4 is what it stays. So 71.24, and we drop everything to the right of that. Now finally we have the 1000th, so 71.2427. So this now is our rounding digit, and this is our test digit. Well, this time 7 is greater than or equal to 5, so that means we're going to round that up, and so that gives us 71.243, and we drop everything else after that. And so that's how we can round to the 10th, the 100th, and the 1000th on the same number, and it shows you what the differences look like. You know, we have 71.2 for 10th, 71.24 for the 100th, and 71.243 for the 1000th. All right, so comparing decimals. Well, with decimals, what we can do is we can add trailing zeros. So, you know, we could add all these trailing zeros out here to make it equal to this one. So we could add 3 zeros so they're the same size. And it doesn't change the value of this. 71.2000 is still 71.2. And so what we can do then is use that to compare the values. Now, if we have positive decimals, we're going to do one thing. So we add our trailing zeros so both numbers have the same number of decimal places. So that's our first thing we have to do. Then we're going to compare digits in each place moving from left to right. And so hopefully we're going to have the same whole number part, and all we're really looking at is the decimal number. That's the only reason we're going to look at this. And so then the first place our digits are different for a positive decimal number. Again, this is the key, is the positive. Then the number with the greatest digit is the larger number for positive decimals. Whereas for negative decimal numbers, again, we're going to add all those trailing zeros so they have a number of same decimal places. We're going to compare the digits moving from left to right. And here, the number with the greatest digit is the smaller number. But again, that's only because these are negative decimals. So the one that's smaller is going to be the one that's going further to the left, and so it's going to make it a smaller number if it's a bigger number. Okay, so let's look at some of these for examples. And, you know, even though we have different numbers, so we have 1, 2, 3, 4, 5, 6, 7, 8, and we have 1, 2, 3, 4, 5, 6, 7. So that means we can add 1 0 here. Now we just start looking. Well, the 3 is the same, 0 is the same, 3 is the same. 8 is different than 6. So this is a positive number, and so is this one. And so which one is bigger? Well, 8's bigger, and for positive, the one that's bigger is going to be the larger number. So that is going to be bigger than this one. All right. Now let's look at this one. So we have 1, 2, 3, 4, 5, and we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So we can add 2 more here to be the same. Now we don't have to, but we can just in case we need to when we get there. So our 18, that's the same, so we don't have to worry about that. Then we have a 6, we have a 6, we have a 2, we have a 2, then we have a 1, and the 9. So that position in the 1000th position is the difference. Now the 9 is bigger than 1, so that means this number is larger because again, it's a positive number. Okay, and so then we write it as that number is bigger than this number. Now here's the different one. These are both negatives, so when we find the one that's larger, that's going to be the smaller value. So we have 1, 2, 3, 4, 5, 6. We have 1, 2, 3, 4, 5, 6. All right. So we look, you know, 0, 0 is the same on both of them. And then we get to the next one. We have a 3, and we have the 4. So the 4 is the greater number, and so it's because it's negative, it's going to be the smaller number. And so this one is larger than this one. And again, if you need to draw it on the number line, that's fine, whatever you need to do. But remember that the key is the negative ones, the one with the greatest digit is the smaller number. And so hence, this is the greater digit, so it's the smaller number. Now that's everything for 5.1, and I will do another video with some more examples.